Hello, and thank you for joining this webinar on HANA Architecture. I'm Robin Webster, Director of Technology and Services at Centec.
Hi, I'm Steve Stringer. I'm a SAP HANA consultant here at Centec.
This webinar is for people with a need to design a HANA-based SAP solution. And we've been designing HANA infrastructure or SAP infrastructure since, well, for over 10 years, and HANA-specific solutions since 2011. So to start with, we're going to talk through some of the design requirements and flush out all of the things that will impact the architecture of your SAP estate. We'll go into the detail next and talk about your architecture choices when it comes to a HANA system. So there'll be some technical content then. We'll talk about testing, what you need to think about to test your infrastructure once you've got it in place, and that's part of your design setup. And we will share with you some of the lessons we've learned in doing this several times before. So we'll start with the design requirements and specifically sizing. So you need to work out how big the problem is to start with. There's a number of ways that you can do that, isn't there, Steve?
Yeah, so to get a sizing, it really depends on what your starting point is. So if you're currently an SAP customer and you're porting an SAP product over to HANA, the most likely way that you'll get your initial sizing is by running one of the standard ABAP programs that are normally in the system or can be downloaded through S-Notes. So there's ones for ECC and BW and going to S4 and such like that.
You'll need to be at a specific version, won't you? Some of the older ones you might struggle to get those programs.
Yeah, we had one customer on BW 3.5 trying to go to HANA, and the scripts on those systems didn't work. But they were massively behind where they should have been. So if you are implementing a new product and you don't already have that particular SAP product available to you,
what they call a greenfield.
A greenfield installation, then you're going to be using the SAP Quick Sizer. Now that's quite a complicated tool, and you need a lot of business input to run it. So you're probably going to need some sort of consultancy and some assistance in order to do that and get an accurate sizing.
Okay.
Now, if you've got a existing non-SAP database, maybe a data mart, something like that, and you want to port over to HANA, then there are some database scripts you can run, provided by SAP, which will give you an estimate of the size of that database in HANA, because it will be different. Even if your current system does have compression, the compression can be slightly different in HANA, so you really do want to go down one of those three approaches to get your initial size.
And these scripts are going to be looking at the data types, I suppose, and looking at the level of different data that's in them to estimate what it'll look like
exactly.
in HANA.
Exactly. So HANA works. HANA's compression comes from dictionary compression through having pointers to original values. So the more variety in a table, the less the compression.
Cardinality of the data, they say.
Oh, absolutely.
Yeah. So, where are we? Estimating growth. So it's going to be an important thing, isn't it, to then look at how big the system is and how much it's going to grow. You'll know some information from your business in terms of what things are happening. You'll be able to estimate growth, but it is quite a challenge to do this, isn't it?
Yeah, it's not always easy. And again, because of so you may understand that you're going to grow by a certain number of records or a certain percent every quarter or every year, but exactly how that will manifest in terms of physical growth of the data footprint, it's sometimes difficult to tell. And again, it comes down to cardinality. Say if you're growing in master data, which is generally quite unique, then your actual data footprint will grow larger than just maybe inputting sales data, which is lots of referential keys being inputted into a table.
So you can try all of these methods, and then actually measuring it, doing it for real and measuring it might be the only way you get a really accurate estimation. But you can, and measuring it once you've got it in the system and you're live, that's going to be really important as well. So part of your sort of growth, you wouldn't want to know when this growth tails off, of course. So what are my retention periods? How long am I going to keep the data? Which takes us on to the next slide, where what we've done here is suggested the kind of table you should try and build up to decide how much data I'm going to be keeping in memory. Now, because HANA is an in-memory database, your primary storage location is memory, not disk. So the cost of data storage in memory is going to be dramatically different. So you may have had an ECC system where you've kept 18 years worth of data and it's on disk and limited cost. If you try and sort of size it, thinking I'm going to do it all in HANA, you could have quite a surprise bill on your hands. So you're going to need to have a look at it and think realistically, what do I really need in memory? Now, when you start to try and ask these questions to your business, it can be a bit of a challenge, because if you say how much data do I want should we keep in our system, they'll always say keep all of it. How much should we keep in memory? Well, all of it. It's too binary. So what you need to do is try and suggest some kind of cost component to this. How much is it going to cost? And maybe go to them with some suggestions. Maybe you say, why don't we keep this amount of memory, this amount of years in memory, which will cost this, and this, which will cost this. Then you add the cost element to it, you're much more likely to get a decision.
And data retention really applies very strongly to large systems, like large historic ECC systems, for example. Maybe if you're looking at a kind of targeted data mart where the data is transient, then that data will maybe always be in memory. Or you know, it does depend on the workload. So
absolutely,
in many cases, you know, it could be that all the data will be in memory all times, and you know, in other cases, it may be that you do need to have a good look at the retention, the life cycle of that data.
Absolutely. Even if when you've done your first size and you think, yeah, we can fit it all in memory, then it's still worth doing this exercise though, because obviously that problem's not going to go away. Eventually, if you keep your system for many, many years, it will grow and grow and grow. So it's worth having the archiving conversation right up front, because it impacts the way you architect your entire system. Okay, so the next thing that will impact your architecture is your business continuity objectives. And what we mean by that is the different elements that could fail within your system, and what we want to do about it, or how quickly do we want to recover. And so again, I'd recommend you set up a table of the possible things that could fail, the different bad events that could happen, and suggest how likely they're to happen, how frequently they're likely to happen, and then what will the business accept as some kind of recovery time. So here I've gone from the most likely things to happen at the top, so disk adapters, networks, and you'd expect to be able to recover from those very, very quickly if there was one of those failures. So and then progressively down the table, you get things that are less likely to happen, but they can have a bigger impact, and then you probably have a higher acceptance time. And it's worth setting these out right at the beginning, so you have a sort of a conversation with the business, because you might be surprised how much they are actually accepting. And I think it's worth writing them down, because it's very easy to get caught up in a best case for everything, which can just add spiraling costs to your entire infrastructure, because it gets very, very difficult with these big systems to have a very, very quick recovery time, very, very quick recovery point in all scenarios. You're saying, Steve. So, and you can use this as the basis for your testing plan later on. We'll discuss that later. I'll just quickly flick on to the next slide. So here I've taken the same table and suggesting what the kind of impact on your architecture might be. So again, right at the top, the basic stuff like disks, adapters, network. You'd expect there to be within a single node in your system. You wouldn't expect to see a single point of failure. So you wouldn't expect to see any one of those components bring the system down. As you start to go up the architecture, bigger and bigger components, the RAID controller within an appliance is typically a single point of failure. So if you want a very quick recovery time for that, you're going to need to build some resilience outside of that single unit. And we'll talk about high availability in the architecture bit later on. And so that sort of continues up and up the stack.
And I think it's fair to say as well that there's many different ways that each one of these particular failure events can be mitigated as well.
Yeah.
You know, for example, with the RAID controller failure, mitigation could be to move to a TDI approach rather than appliance,
yeah.
or it could be to add more redundancy. And it really is a case of balancing the customer's requirements with the cost and what the availability SLA is as well.
Absolutely. Okay, so and finally in this section, the agility requirements. If we go on to the next slide, please. So I've listed a number of potential requirements that you might have within your organisation that might sort of make an impact on the architecture. So firstly, if you're architecting for a high number of SAP products, so you've got ECC, you've got BW, you've got
SCM, APO,
you know, the list goes on and on and on sometimes. You might have lots and lots of differing requirements in terms of versions of components, and it can get very, very complicated. But if you purely go down the appliance route, you could end up with an awful lot of hardware with lots of very big physical boundaries that will be difficult to shift when the situation changes. So if you want to be very agile, maybe some of these components, you're not even 100% certain they're going to be implemented, but you're trying to get the infrastructure in place that you're able to. We've seen decisions change along route, haven't we, Steve? So that and if you've bought the hardware and it's appliance based, it's very fixed, you can have some challenges. So it might be that virtualization will help your project delivery, but also reduce that wastage and you know, through the consolidation benefits. And then when it comes on to increasing the size as well, so again, you know, with virtualization, if one of those individual components increases in size, you've got the potential to move those boundaries between the different applications, because they might grow at different rates, so you get a bit of different sort of choice there. Well, actually, when it comes to the physical units themselves, if you've got very big workloads or ones that sit on the thresholds between the different physical devices, then that might impact your choice, mightn't it, Steve? Because there's certain boundaries, isn't there, like 4 sockets?
Absolutely. And it's fair to say as well that some appliances, some bits of hardware scale more elegantly than others. So, you know, some it's a case of plugging in components from in the front. Some it's a case of taking a whole box apart to add more memory and more CPU. Yeah. And yeah, there's also boundaries and sweet spots where, you know, say a customer deploys 2 terabytes, they think they might need 4 in the future. It's about getting that information up front so you can design an easy upgrade path. Yeah.
But all of those upgrade paths tend to come with extra cost, don't they? If you know, so if you,
I'm sure many customers would like to upgrade for free. Yeah.
No, but in terms of if you know exactly what you've got and it's going to stay the same for 5 years, you pick an optimal one for that particular situation. If it's a requirement that you think is going to likely to increase in size, or there's a good chance of it, you might pay the extra for the bottom of the next tier up, for example.
Yeah.
You know.
Absolutely.
Next, the need to rapidly refresh QA and pre-prod. So occasionally we talk to, well, quite frequently we talk to customers who are in a position where their test systems don't get data refreshes very frequently, and that can lead, certainly in an analytical platform, that can lead to situations where the thing they want to test is a big query, a big report or dashboard. And the only place they can really test it to get results that are meaningful is in production, which is clearly not a desirable situation. So one of the reasons they might have a challenge in refreshing that data is because they're massive data sets. So if that is something that is a concern for you, and you've got lots of, so you've got this desire to refresh QA frequently, then you might want to design that in right from the get-go in terms of how you architect your refreshes. And so I mean, I've mentioned here storage snapshots being one possible assistance.
Yeah, storage snapshots. I mean, there's other way to quickly restore systems as well. But also, there's there's only half the problem, because the other half is at the often at the ABAP layer, and there are tools available that can speed up the system copy process as well.
Yeah,
but again, cost those in at design time, and don't try and add them to the project later.
Absolutely, because they won't happen, will they? Get everything in whilst you're in that budgeting phase. Otherwise, these tools that will just make the whole thing slicker and enable you to get the real value out of the expensive implementation you're going for, will just get lost and missed. So think about them right up front, which neatly brings us on to the DevOps elements. So to get the real value out of virtualization, if you have gone for a flexible environment and you do want the ability to be agile, you really want to build in ideas like config management and efficient build methodology, all of the sort of tools that you might possibly want to have that flexibility. They want to be built in right from the beginning, don't they?
Absolutely.
And consistency across your estate is also really, really important for a happy life cycle, isn't it, Steve? So having those config tools really helps.
Yeah, I mean, avoiding the snowflake servers, you know,
Absolutely.
the consistent set of tools and firmware and patch values across a architecture make everything so much easier.
Yeah. So let's move on to the architecture choices. Thank you. So we're going to talk a little bit about scaling.
Okay, so one of the things that we often talk about is the difference between scale out and scale up. So scale up is really the principle of having one single operating system with one installation of HANA running on that operating system. And scale up, what we're talking about is, they can start small, so any standalone HANA instances scale up, but with scale up, you add capacity vertically within the same operating system. On the other hand, we've got scale out as well. So scale out is when we've got multiple operating systems with the same single HANA installation across the landscape. So again, it's just one installation, but it exists in multiple places and runs in parallel on multiple servers. Now, scale up is really suitable for SAP Business Suite and S4 systems. The scale up size tops out at about 24 terabytes.
It's fair to say that there aren't that many infrastructure platforms that support that size, are there?
No, once you go beyond 8 sockets, once you go beyond the 8 terabyte limit, you're talking esoteric hardware, really. You know, stuff that doesn't get deployed all that often, and you can pay a premium for these larger systems as well. So in terms of BW, we're looking at around anything less than 6 terabytes, and any modestly sized data mart would also be suitable for scale up. Now, scale out, we're looking at large Business Suite and S4 systems, but it is worth mentioning there's a SAP note that says if you can't scale out S4 or Business Suite until you hit 6 terabytes.
Yeah.
So for various technical reasons, mostly complexity though, a scale-up system is always less complex.
And the Business Suite, I think, is on application only, isn't it?
Yeah, that's right.
It's a bit more restrictive, isn't it?
So S4 scale-out is supported generally.
Yeah.
Before S4, it's on a case-by-case review.
It's worth mentioning, for good reason, they encourage you to scale up as much as possible before you scale out, because it is more complicated. There are some management overheads in terms of how you spread your data across those systems. We've got lots of customers who use scale out for BW, and it works very well. But there are some overheads in terms of the added complexity and complications of running many systems. So some of the early adopters who are running half terabyte systems, if we were to refresh, we'd try and scale up where possible, wouldn't we, to remove that complexity, improve reliability. And
I think it's fair to say that as well, OLAP with its it's got more of a predictable querying pattern. You're doing large table reads, aggregations, and stuff. Where transactional stuff, you're doing lots of small updates, and that can be complicated in the scale out world. But really, just to hammer the point home, with scale up, we've all our database objects sit within the same host. Whereas with scale out, those database objects can be distributed throughout the landscape. Now that distribution isn't automatic. On BW systems, it's done algorithmically with a little bit of manual intervention.
Yeah. So there can be an overhead to get that balance right. There can be some work needs to be done to sort of work out how to get the balance right across those nodes, which can be looked at in two flavors. It's the balance of data volume and also the balance in terms of the access, what actually data has been accessed on each system. They can get complicated. We'll talk about that in a later webinar.
Fantastic. Right, so let's move on. So obviously, one of the big questions that we get when we architect these systems are around high availability. So when we talk about high availability, what we really mean is the ability for HANA to carry on working on a separate bit of tin, maybe, after the failure of one of the nodes, or the single node if it's a scale-up system. There's really three main methods available to us, which are the host auto failover, the host level clustering, and the container restart. So let's have a look at host auto failover first. So what we have in a host auto failover is a scale out system. So all of the nodes will be given a I can't think of the best word right now. They'll all have a role assigned to them. And one or more nodes will be set as a standby node. It's generally one node. You'd have more than one node in a very large system, but that's we're talking sort of 20 nodes plus perhaps. So one node would have a designation as standby, and all that it really does is when a primary node fails, it takes over that worker's role. Now, it's quite straightforward, but it does take a little time. Firstly, the standby node has to realise that the worker node has failed. So there's something like a 2-minute timeout with that you can't alter. That's an internal setting to SAP. Once it does time out, the standby node will need to load the row store of the failed node, and then after that row store has been loaded, it can start servicing requests.
So if it's the master node, then typically it could take the longest because that has all higher level of row storage.
Yeah, generally speaking, yeah. But then once it's got the row store loaded, it then has to start loading the column store in the background, which can take several hours. So you can have a performance hit for several hours after a failover.
Yeah. And so this method only uses the SAP toolset. There's no additional.
Yeah, it's completely native to SAP. It's
all within the HANA toolset.
Absolutely. But it's also worth pointing out that you can do this with scale-up nodes where you just have one worker and one standby. But if you have got scale-up, there's perhaps better ways of doing things.
Which is your next
which brings us on nicely to the next slide, which is our host-level clustering. So if we're using host-level clustering, what we basically have is two HANA systems that are surrounded by a layer of clustering. So Red Hat and SUSE both supply Heartbeat and Corosync resources for the Heartbeat and Corosync stack to externally provide high availability within HANA.
So in the last model, the data is actually on a shared file system or a shared LUN that moves. In this one, you've got an arrow going between the two. It indicates replication between the two.
It is replication, so they are
just HANA-based replication.
Yeah, so it uses HANA system replication under the hood, and it provides a high availability layer underneath.
Yeah.
So because it's a cluster, we have all the things that you'd expect in a cluster, like a virtual IP address, but we also need to prepare it in the same way as a general cluster. So we need a Stonith method for fencing, for example. So we generally suggest the storage-based depth method, so by providing storage LUNs to the system, either fibre channel or iSCSI, or preferably both.
Yeah.
So if the secondary notices that the primary fails, then what happens is the virtual IP address moves over to the secondary node, and then we perform a system takeover automatically as part of the cluster. Now the nice thing with this solution is the replication can be synchronous, near synchronous, or asynchronous, depending on the distance and the bandwidth between the systems. And the replication can also be done in two ways. So it can be done as delta shipping, which means we can have quite a small footprint of memory, so we can actually make use of this node, so it's not completely redundant. So we could run a test or a QA environment on there, which then turns off when the node needs to be used for production. that does increase the failover time. So if it's a real mission critical system, what we can do is we can have the secondary node running all the memory and data simultaneously. And when you run like that, the failover can happen within seconds. So,
Right,
so imagine a scenario where you've got a warehouse or something like that. Items can't be picked unless the database is up.
Yeah.
You know, you don't want guys waiting around for minutes, you know, with no instructions. So,
Yeah.
you know, those mission critical sort of applications then would benefit from the very high speed takeover.
And this is the scenario you were saying better than the basic HANA clustering, in so much as you've got the data already on the second node.
Yeah.
So,
But
you haven't got that latency to load the data.
exactly. And what we can do is we've got a table coming up in a couple of slides where we can compare the technologies.
Yeah.
So our final method of HA is a container restart. And what we mean by this is where you'll be running HANA, maybe in the public cloud, maybe on virtualization, but it really, you know, relies on that. So you have HANA running on a host. If that host fails, HANA will automatically restart on a redundant piece of hardware. So this could be managed by something like CloudWatch or VMware, you know, on a private cloud basis.
Yeah.
So what it does rely on is external replicated storage at the back end, and it's really the lowest cost method for HA. Now what you need to consider though is, because you are literally restarting the operating system, then the recovery time is a lot longer than the other options that we've seen. So the operating system's got to start, and then once that's started, HANA's got to start as well. So
Right.
you know, it's you know, I think well, we'll get on to the comparison in a minute.
Yeah.
Well, let's just move there now. Actually, it's a
Yeah.
good time to do it. So if we compare all the options, let's go across the board and talk about complexity. So the container restart and the auto host failover, they're relatively simple to implement. You know, auto host failover is native within SAP. Container restart is native within your virtualization layer. Now, host level clustering is a lot more complicated. It relies on you know, separate network links, separate storage links, you know, all to manage the cluster.
You're going to need a high level of understanding of this, or it's kind of the Linux layer, aren't you?
Yeah,
to do
absolutely.
That bit, it tends to be
Absolutely.
Yeah.
And you know, luckily we've got very good Linux people here with some very good training.
Yeah.
And you know, so we've implemented quite a lot, and very successfully. So let's have a look at the infrastructure footprint. So with auto host failover, it's really well suited to scale out because it's an N+1. So if you need 4 nodes, you know, that's the number of nodes to run the data, then you only need 1 more node to provide the HA.
Yeah.
So you know, it's quite economical, especially when the node numbers get high.
And we've had this. This is very popular in the BW world, isn't it?
Exactly.
We've got lots of big scale out clusters and just one additional one for that hardware resilience, minimal extra cost.
And with the container restart, that doesn't. It's difficult to quantify because you know, if you're in the public cloud, then you're not renting that box that it restarts upon.
Yes, certainly in the cloud scenario, yeah. If one of those boxes fail, you rely on the fact that they'll find another box for you to fire up that same image. We need to bring it into the data center. Of course, it's still advantageous, isn't it? Because you can have a cluster of systems within VMware, and you just have a degree of redundancy, a node extra. But you can use it, can't you? So you can.
I believe they call it anti-affinity rules. So so you can say this guy is more important than these guys. If that node's down and this guy needs to run, these guys can get killed.
Right. So when we're talking about the workloads on the individual nodes, you can switch off some of the workloads in order to, in preference for the production workloads.
You can prioritize workloads.
Yeah. So the key thing is you haven't got to have twice the amount of hardware to preserve every system that you might end up doing if you go for a pure appliance model.
Yeah, absolutely.
You know, hardware for each environment.
And then the infrastructure requirement for the host level clustering is N+N. You know, you want one 6 terabyte node, you need a spare 6 terabyte node.
Yeah.
Although, as we mentioned earlier, that can be sacrificial.
Sacrificial, as in sacrificial, you'd have sacrificial pre-prod environment running on it that you sacrifice.
Yeah.
You can reuse it to some extent, but it's not quite as flexible. And you do still end up with twice as much hardware, don't you?
You do.
Yeah.
So speed of failover, you know, we've got 2 slow ones and a fast one, potentially. to cut a long story short. So you can design the host level clustering to be, lightning. It can fail over within seconds of detecting an error, whereas the other two options are always going to be several minutes minimum.
Yeah.
So our auto host failover isn't going to be suitable for DR. You can't have 10 nodes on one site and one node on the other and hope that if one site fails, it will magically all work.
You'd expect all those nodes to be in the same rack or next to each other.
Absolutely. You can use host level clustering across multiple sites as long as you've got the right infrastructure requirements, which are a bit too complicated to go into right here.
Yeah.
And container restart, yes, that can work geographically as long as you've got that data replicated.
And I guess you can use some of the VMware tools, for example, like SRM, to sort of manage that DR.
Or if you're in the public cloud, you can replicate that storage area across multiple geographic regions.
Yeah.
So that's our comparison of those tools. Let's talk about our disaster recovery methods. So, oh, sorry, I didn't do that properly. Our disaster recovery methods. So we've got SAP HANA system replication, which is the cornerstone of that host level clustering we were talking about earlier.
Yeah.
We can use storage replication to recover from disasters, and we can use the traditional backup recovery technology. Now, by disaster recovery, we're talking about a site failure, geographic issue, something like that, fire, flood, that sort of thing.
Yeah.
So, SAP HANA system replication. Now, this slide is very similar to the host level clustering slide, except we don't have a virtual IP address. It's the same technology. We're using SAP HANA system replication, but really we've got it as a manual process. So again, like host level clustering, the replication can be synchronous, near synchronous, or asynchronous. That's really going to depend on the latency and the distance between the sites.
Yeah, it's basically the same thing, but without the clustering technology.
Absolutely.
I mean, typically, the disaster recovery, unless you've got a mixed HADR environment where you've got two data centers together where you can cluster between the two, typically you'd expect the disaster recovery scenarios to be very manual, wouldn't you? There's a load of other components that probably have to move across with your database.
Quite often that's the case, yeah. And the replication mode we can set. We can do the delta shipping again and free up memory on the remote node in order for it to be used for another workload, which we can sacrifice in the case of a disaster. Or we can do the full log shipping, have the whole thing in memory. So even in a disaster, we can get that system up and running very quickly. Super. Let's have a look at. Oh, I didn't run the animation. Never mind. So let's have a quick look at the storage replication option. So it's very similar to system replication, except that you replicate at the storage layer. So it relies on having enterprise storage available to the system, so not appliance storage typically, but an external subsystem that allows replication. So the exact replication types would differ between the storage vendor, but it works in a very similar way to HANA. You get an error on the primary site, and you basically run an operation in order to make that data live again on the secondary site. So it's very similar in terms of operation, but there are some operational differences that we'll talk about on the comparison.
Yeah, this is the scenario that opens up the opportunity to have much faster snapshots and QA refresh.
Yeah, if you're going to be using enterprise storage, you may as well make advantage of it by doing snapshot backups and stuff. And those snapshot backups will enable you to do the replication and not the replication, but the recovery
refresh.
Okay, so let's have a look at the backup and restore. This is very high level, this slide. So we've got two geographically separated HANA installations. One of them backs up to the enterprise backup solution. And in this case of a site failure, we simply use that same enterprise backup solution to restore the data to an alternative system. So it's probably best if we talk about backup and restore real quick and talk about what the options are. So our backup options with HANA is we can back up to flat files. We can export the whole data structure down to a few files. We can use what they call the backend API, which is the API that the backup software vendors use to integrate SAP HANA into their product. So people like Spectrum Protect, formerly TSM, Networker, Net Backup, Commvault, all these guys work with SAP on the API. And we can use storage snapshots, as we mentioned just a moment ago, in order to rapidly back up systems. So let's compare what our options are. So let's have a look at recovery point. So both HANA system replication and storage replication can be sync or async. So if you're looking at synchronous replication, you know, the system can be restored to the point of last transaction, last committed transaction. So that's excellent. Now async, that's always going to depend on distance to the sites, traffic, etc. But we see many async systems, even on full load, you know, being no more than a couple of seconds behind. On many of our customers' sites. Now with the backup and restore, you're always going to be stuck to restoring from the last written log backup, which could be anywhere up to 15 minutes old. Now you can draw down that window and make it shorter, but probably you don't want to go under like 300 seconds.
And of course your recovery time is going to be down to the time it takes to recover the actual last full backup, but then also the time it takes to roll forward to that recovery point.
Yeah, exactly. So that's the next line down, the speed of the recovery. And it's going to depend as well on the volume of the data, how quick you can get it out of the backup product, and
also, you know, when the last successful backup was. Backups are notoriously the most difficult thing to sort of keep reliable. They're the things that keep operational teams busy, and so it's not unheard of to have a couple of failures in backup. So then you are talking maybe you could be looking at 2 days worth of roll forward, so that could be a significant amount of time.
Yeah, it could be, and especially on a busy system. So the speed of recovery in terms of HANA system replication, because it's native, you know, it's very, very quick. You know, it can be seconds in the full log replay mode, or minutes in the Delta shipping mode. Rarely seen it take very long. Now with the storage replication, because there's a number of configuration steps to do, you know, like repointing the LUNs, restoring a chat snapshot, etc., then that, you know, you would expect to be up and running in less than an hour.
Yeah, it depends on your replication methodology as well, doesn't it? Some of them are sort of snapshot based, aren't they? So they go across periodically. So you might still have some roll forward to do to get to that recovery point. So that's all going to add up to the recovery time.
Absolutely. So technology requirements with HANA system replication, you know, you need like-for-like systems either side. You know, if it's a 6 terabyte system, you'll need a 6 terabyte system on the other side to replicate to and to restore to.
But all the technology's there already. You don't need anything additional.
You don't need anything additional. It's all, you know, HANA native. With storage replication, yes, you'll need the same. You'll need enterprise storage at both sides. Yeah, for storage to replicate from one to another, they certainly need to be the same manufacturer. More than likely, the same model of storage as well. So you are going to need the same stuff at both sides, if you like. Backup and recovery, you know, you don't need anything special other than you need the access to that data. So if you're backing up on site A, if you intend to use it for DR, you've got to make sure that data is replicated in some way so it's available in site B. And that could also affect your RPO as well. Okay, so let's now move on to testing and lessons learned.
Yes, so we mentioned testing early on, and we talked about the business continuity objectives, and that's a good point to sort of start your breakpoint analysis, have a look at what might break, and then start to build out a test plan as part of that design process. It's also a great opportunity to flush out all of the monitoring requirements for your testing, or rather for your system. So when you do your test, does your monitoring reflect the failure that's happened? You don't want, it's pointless having removing single points of failure if you don't have monitoring to pick up when one of those redundant items fails. Otherwise, you are going to be running on a single point of failure for an extended period of time until someone spots it.
Or until you fail in a big way.
Yes, or more likely until it fails in a big way. You want to do your complete DR test. So, you know, we see lots of customers do sort of test, or maybe test the database and go, great, there's a success, you know, because we're just doing a HANA thing. You know, they're not doing a complete DR test. if you're putting in a whole load of new infrastructure, you should always test all those assumptions on what works, what doesn't work, what will happen as part of that test. The actual process for doing DR can be very complex. You can sometimes have multiple people involved, multiple steps in the system. So get it all tested as soon as you possibly can, because the longer you leave it, the harder it is, and it may never happen in quite such rigor. You need to flush out all of those problems as early as possible. And the same for any of the operational processes. So you might, along the way, have designed in the ability to do maybe, say, a firmware upgrade of some of your hardware. You're going to move all your workloads to another system, do the firmware upgrade, and then move them back. Great. But prove you can do it, test that you can do it, and test to see what the impact is. Do the applications still work? All the applications, can they still see it? Are there any firewall issues or any other things like that? I just want to get them all flushed out.
One of the things that I like to do when putting a system in is to baseline the system. So you get a firmware baseline, a patch level baseline, and re-baseline the system before go live.
Yeah.
So that you can run through a full firmware through a full patch cycle.
And so that'd be a great opportunity, wouldn't it, to prove all of those
absolutely.
theories,
Absolutely.
It might be another year before you actually do them. So. Get them done.
And most importantly, have a thorough OAT plan. When we work with people with a full OAT plan, that's how it works best.
Yeah. So, what lessons have we learned? Well, iterative approach is often best if you sort of go in.
We're back to talking about design as a whole now.
Yeah, design as a whole. Yeah. So, you'll find that. You might come in with the sizing thing, an enormous size. We have customers come to us and say, I need a 10 terabyte system, and then you sort of show them what the price might be for a 10 terabyte system. They reconsider it. They start talking about their data lifecycle management, all the rest of it. So you start in small slices, backwards and forwards, so it starts to take shape, rather than too much detail right up front. So iterate over those ideas. Please consider monitoring right up front, and all your management tools. These are the things that get pushed to the end, and they're the things that keep you with a really successful operating system, successful operating model. You're spending all the money to create all of these resilient architectures, and if you don't have the operational process, the tooling in place to make sure you meet those objectives, then there's a whole lot of money wasted. So keep them in the design process. Use config management tools. I've said it before, sound investment. You want consistency across your build. You don't want to be hearing that it worked in dev, it worked in QA, but it doesn't work in prod. They want to be identical so that you don't have these issues. If you're trying to recreate an issue that you have in prod, you have a good chance of recreating it in test because it's the same. And use cost to drive decisions, all of the decisions, but specifically data retention decisions. Don't go to the business with open questions. Drive them towards a decision by telling them what it's going to cost them, and then you'll have a better design experience right from the beginning if you do that. So we'd like to finish by saying we're here to help. You can come to us and we'll help you with architecture design. You've probably appreciated that from the detail we've given you in just this short space of time. There's loads more decisions to make that we probably haven't mentioned. Try to cover it all there, but there's an awful lot of complexity there, so we can help you with that process.
We've also got the, if you're thinking about deploying HANA in the cloud, we've got the SAP HANA Cloud Readiness Assessment, so we can look at that in fine detail. If you've not really made the decision on the platform, we've also got the SAP HANA On Assessment, so we can take a look at your approach, we can take a look at your applications and help you advise what the best platform for your scenario is.
And if you've already come on to HANA and you want to make sure that you're making the best of it, then we've got one of our many mini packs that we're developing to help you optimize your HANA system, make sure that it's running healthily, and you've got your best
Absolutely. Cost. Make sure you're not going to fall into some of the pitfalls that do exist on these platforms.
Yeah. So we've already done one HANA On a webinar. The link is in the presentation here. I think we're going to share the presentation with the people who've joined, and we shall put this one also onto YouTube as well. And then we've got a couple more coming up. So the next one's the building the HANA journey from a business case. We'll try and sort of flush out some of the benefits of running HANA systems from a business perspective, and give you some ideas on how you can help justify moving into the new world of HANA. And then following that, we've got SAP HANA operational best practices, optimizing HANA for performance and cost. So we'll go into some of the ways that you can make HANA really work for you for the right price, the right performance, and dig into how to make HANA really the most optimal solution you can have. So thank you very much for participating with us. I don't know if we've got any time for questions, have we?
Yeah,
running out of time?
some questions. If anyone would like to raise their hand or type one into the question box.
So I'll just give you a few minutes if anyone's there who wants to ask a question. How long did we take?
Don't know.
45 minutes. Wow. You talk too much, Steve.
That's the problem.
Okay, thanks for leaving there.
Okay, no questions. Thank you very much.
Thank you very much. Join us again.